Hi, I'm Jesse Antushik, and we are the Drum by Mouth team, the remote wireless hi-hat project. I worked on the communication system for this project.
I'm Bradley Kahn. I did some work with, putting together an interface with the hardware, between software and hardware, and put together part of the calibration module.
I'm William Stewart. My main focus was on the packaging, so I helped design the wearable backpack design as well as the floor box and the mouth guard.
My name is Lucky, and I was responsible with the mechanical part of the project as far as mounting the servo.
I'm Brandon Ahrens. I did a lot of the hardware involved with this project and a little bit of the software. So our project solved the problem of a disabled drummer not being able to actuate his hi-hat because he doesn't have the use of his legs. Our project also solves the problem of not being able to use a hi-hat if you're using a double bass drum setup. So our project is a wireless mouth guard that you put in your mouth, and when you bite down on it, it actuates the hi-hat as you bite down.
So general system overview. This is a force sensor, and when you push on it, the hi-hat actuates, and you can have it open or closed or partway closed. So there's an analog to digital converter in here that is sensing how hard you're pushing on the sensor. It takes that reading and sends it to the other side. So we've got another box right here with another wireless module in there that receives that signal and sends it to the servo, which actuates the hi-hat.
All right, so we had three real major problems with our design, our system as we were building it. One of the big problems was that the servo would jitter up and down a lot. There was a lot of noise in the signal, and we tried a lot of different things to fix that. We tried hardware filtering on the receiving end, software filtering on this end to sort of clear it up. And we also tried using a hardware PWM shield to see if maybe the Raspberry Pi couldn't handle the PWM as efficiently as we wanted it to. So what we ended up figuring out was the issue was that we were sending it signals too quickly, faster than it could read. So after making some adjustments to that, we ended up totally eliminating the jitter and the noise from the signal, so it holds fairly stationary. Another problem we had was with the servo overheating when it was held down or being used for too long. One of our solutions was to get a more expensive servo that was more efficient with its energy, and then we also added some heat sinking. And then the last major issue that we had was molding the mouth guard, which we're still having some minor issues with. Finding the right materials, because the first material we used wouldn't embed the pressure sensor, it would fall apart. Then the material we're using now is giving us inconsistent results, so we're going to have to figure out the best way to make sure that we don't have any issues with that so that it works the way it's meant to.
I think generally just planning ahead and expecting things to fail a lot was one of the skills that maybe we didn't have going in. A lot of things did not work on the first try, and so we had to rapidly iterate on basically every part of our project.